Ladies and gentlemen, please be seated.
To mark the official start of our event, it is now time to invite our distinguished leaders to deliver their opening remarks.
First, it is our privilege to invite the chairwoman of the 6th ICVMHS 2026, Lina Susanti, Doctor of Veterinary Medicine, Master of Science, Doctor of Philosophy, to deliver the opening remarks. To Dr. Lina, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. The Honorable Rector of Universitas Airlangga, Profesor Dr. Muhammad Madian, the Vice Rector, Profesor Insinyur Muhammad Amin Alamsyah, the Dean of Veterinary Medicine Faculty, Profesor Dr. Lili Maslahah, distinguished keynote speakers, esteemed colleagues, researchers, practitioners, students, and participants. It is my great pleasure to welcome you to the 6th International Conference on Veterinary Medicine and Health Science 2026. This year's theme, Building Resilient Animal Health System, a One Health approach to veterinary medicine and animal husbandry, highlights the importance of collaboration in addressing today's global challenge, including emerging diseases, antimicrobial resistance, food security, environmental sustainability, and animal health. Through this One Health approach, we recognize that well-being of animals, human, and also the environment is closely interconnected. The ICVMHS continues to serve and strive as the international forum for researchers, academicians, practitioners, and students to exchange scientific knowledge, present innovative research, and strengthen the global collaborations. We are honored to welcome distinguished speakers and participants from various countries whose expertise and contribution, we believe, will enrich the discussions of this conference. On behalf of the organizing committee, I sincerely thank everyone supporting this event, the speakers, authors, reviewers, sponsors, supporting institutions, and all participants. Thank you for being part of the 6th ICVMHS. I wish you a productive conference and enjoyable scientific experience. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Lina, for those insightful opening words. Next, we would like to invite the Dean of the Faculty of Veterinary Medicine, Universitas Airlangga, Profesor Lili Maslahah, Doctor of Veterinary Medicine, Master of Health, to deliver the welcoming remarks. For Dr. Lina, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Dear distinguished keynote speakers, honorable guests, college researchers, practitioners, students, and participants. It is my great pleasure to welcome you to the 6th International Conference on Veterinary Medicine and Health Sciences, or ICVMHS 2026. Hosted by the Faculty of Veterinary Medicine, Universitas Airlangga. This year's theme, Building Resilient Animal Health System, a One Health approach to veterinary medicine and animal husbandry, reflect our shared commitment to addressing global challenges through scientific innovation, interdisciplinary collaboration, and international partnership. As the health of animals, human, and the environment become increasingly interconnected, the One Health approach remains essential in shaping a healthier and more sustainability future. The Faculty of Veterinary Medicine, Universitas Airlangga, is proud to provide a platform where researchers, academicians, practitioners, and students from around the world can exchange knowledge, share research funding, and strengthen global collaboration. We believe that every discussion and scientific contribution presented at ICVMHS will inspire innovation and create meaningful impact for veterinary medicine and animal health. On behalf of the Faculty of Veterinary Medicine, Universitas Airlangga, I sincerely thank for keynote speakers, authors, reviewers, sponsors, supporting institutions, and all participants for your valuable contribution. Your presence and commitment make this conference possible and strengthen our international academic community. I wish you an inspiring, productive, and enjoyable conference. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much to Professor Lily for your inspiring remarks.
Next, we are deeply honored to invite the Rector of Universitas Airlangga, Professor Dr. Muhammad Madian, Bachelor of Economics, Master of Science, Master of Finance to address the Assembly and officially open the 6th ICVMHS 2026. To Professor Muhammad Madian, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. It's my great pleasure to welcome all distinguished speakers, researchers, academicians, practitioners, students, policymakers, and all participants to the 6th International Conference on Veterinary Medicine and Health Science 2026, organized by Faculty of Veterinary Medicine, Universitas Airlangga. This year's conference, carrying the term Building Resilient Animal Health System, One Health approach to veterinary medicine and animal husbandry, reflects an important and timely commitment to addressing complex global challenges in animal health, veterinary medicine, public health, food security, environmental sustainability, and also antimicrobial resistance. This issue requires not only strong scientific capacity, but also interdisciplinary collaboration and global partnership. Universitas Airlangga recognized that veterinary medicine and animal husbandry play a strategic role in the supporting public health, sustainable development, and global health resilience. Through the One Health approach, this conference provides an important academic platform to strengthen knowledge exchange, promote innovation, and encourage collaboration among scholars and professionals from various countries. I highly appreciate the Faculty of Veterinary Medicine of Universitas Airlangga, the organizing committee, keynote speakers, presenters, and all contributors who have made this international conference possible. I believe that the scientific discussion, research presentation, and professional networking developed through this forum will contribute meaningfully to the advance of veterinary medicine, animal health system, and sustainable animal husbandry. May this conference inspire new ideas, strengthen international academic networks, and open broader opportunities for collaborative research and innovation. I also hope that this conference will continue to grow as a sustainable international forum that support the global feasibility and academic contribution of Universitas Airlangga. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Our highest appreciation to the Vice Rector of Universitas Airlangga in the Academics Division for representing our Universitas Airlangga Rector for the opening address and official inauguration of today's conference.
Our rich cultural heritage and welcome our international delegates, we are delighted to present a traditional cultural dance performance, Cunduk Menur Dance, that originated from Banyuwangi, East Java.
The Cunduk Menur dance of Banyuwangi portrays the elegance of village women who serve as pride for their community. The nomenclature of this dance is derived from an isosceles triangle headpiece used by the dancers. Philosophically, this triangular configuration symbolizes interpersonal relationships at the base angles and human relationships with the divine at the acute apex. Sit back and enjoy the show.
officially start our main event. Without further ado, allow me to welcome Hardani Primariski, Doctor of Veterinary Medicine, Master of Veterinary Medicine, Doctor of Philosophy. Dr. Hartanto Mulyo Raharjo, Doctor of Veterinary Medicine, Master of Science, Doctor of Philosophy. And Lina Susanti, Doctor of Veterinary Medicine, Master of Science, Doctor of Philosophy.
Allow me to introduce our first moderator, Dr. Hardani Primariski, Doctor of Veterinary Medicine, Master of Veterinary Medicine, Doctor of Philosophy.
Good morning, distinguished guests, esteemed colleagues, faculty members, researchers, and fellow veterinarians from all around the world. Welcome to the main session of the 6th International Conference on Sciences.
Joining you today as your moderator are myself, Hartanto Mulyo Raharjo, and my colleagues, Hardani Primariski and Lina Susanti from the Faculty of Veterinary Medicine, Universitas Airlangga. It is our absolute honor and privilege to serve as your moderators for today's prestigious plenary session.
Our session today focuses on the critical advancement and collaborative efforts in veterinary medicine and health sciences across the Asian region. Today, we are highly honored to host 4 eminent professors and experts from Indonesia, Malaysia, and South Korea who will share their invaluable insights with us today.
Before we begin, please allow me to announce a few important rules to ensure our session runs smoothly. Each keynote speaker will have 35 minutes for their presentation. Then, the discussion will be conducted in 2 separate slots. The first one right after our second speaker, and the second one at the end of the session. After all presentations have been delivered, attendees can submit questions via the Q&A box at any time during the presentation, or use the raise hand option during discussion session to ask questions directly.
Now, let us officially begin with our first keynote speaker. Joining us from South Korea, Professor Jong-ho Park, DVM PhD. Before the presentation begins, allow me to briefly introduce his professional background. Professor Park earned his Doctor of Veterinary Medicine and Master degree
Okay, am I good to go? Okay,
Not yet, Prof.
okay.
Oke, oke, boleh lagi Mbak. Langsung saya kan Mbak. Oke, oke. So, we are very sorry for a little problem. So we will continue. So Professor Park earned his Doctor of Veterinary Medicine and Master degree from Gangwon National University in South Korea. He then completed his PhD in immunology at Purdue University and followed by postdoctoral research at the University of Pennsylvania in the United States. Currently, he serves as an associate professor at the College of Veterinary Medicine, Gangwon National University.
His prominent research focuses on veterinary immunology, particularly looking into gut metabolites, immune regulation during interspecies infection, and immune responses to avian viral infection.
Today, we are honored to have him share his expertise in a presentation entitled The Interleukin 17A, 17RB axis in hematopoietic stem and progenitor cells, promotes monocytes lineage commitment. Professor Park, the virtual floor is yours and you have 35 minutes. Good morning, Prof. Park. Okay, are you here with us?
Yes, yes. So are you guys hear me okay?
Yes, we can hear you, Prof.
Okay, so I'll get it started. Um, today's great, really my pleasure and honor to participate in the ICVMH meeting. I remember this is my second participation after like a fourth meeting. So yeah, today I'm gonna share my recent research on IL-17 cytokine receptor axis on hematopoiesis. So actually, this is not really directly related to certain animal veterinary medicine study, but as an immunologist, I wanted to share my recent and my ongoing research, even which is not even like published. So I believe this is also add like a good addition to your seminar. So before I getting started, I wanted to thank you again. I visited University of Airlangga early this year to sign an MOA between my institution and Airlangga University, and I had a really unforgettable memory with you, like a warm hospitality, and then I really had a good time visiting like a broad mountain. So I wanted to appreciate Dr. Really Maslaha for your warm hospitality and hope this relation get like a prosper. Okay, so I'm gonna start with my very conventional slide. My talk is about again the cytokine and its receptor axis on hematopoietic stem
Professor
cell
Park, excuse
differentiation.
me.
Okay,
I'm sorry to interrupt, but the slides has been displayed yet in the monitor. Can you
okay.
slide show it, please?
Is it sharing okay?
Wait for a minute, Prof. Okay,
Um,
you can continue, Prof. Thank you.
okay, do you see my slide okay?
Oh, I'm sorry, Prof. The team said that you can use a presenter view option. So
Okay.
we will see your total entire slides only.
I'm sorry, my connection was like disrupted, so I went out and came in again to reconnect. So I'm gonna share my slide again.
Okay, thank you.
And do you see my slide okay? Ah,
슬라이드 노트가 보입니다.
Okay, we already see it, but still in the small display. But if you want to continue, maybe that's fine, Prof. You can continue the presentation. Thank you.
sorry, but the connection is not really good. So I don't. Do you see this moving? The slide moving?
Yes, the slide is moving, but there's some like presenter notes on the right side.
Yeah. Okay.
So we also
Let
can
me do
see
this.
some figures on the right side of the monitor.
So am I sharing my slide okay now?
Okay, Prof.
Oh, now it's
Yeah,
fine.
it's
Prof.
fine.
Okay,
Please
sorry.
continue.
For-
Thank you very
Okay,
much.
thank you.
Okay, all right. Okay, sorry. Okay. So this is very classical and very conventional diagram of how bone marrow originated, like hematopoietic stem cells are differentiated into various myeloid cells. So as you probably all know, GCSF, MCSF, and GMCSF is the major cytokine that are leading to differentiation of hematopoietic stem cells into each functional myeloid cells, such as granulocyte by GCSF and monocyte and macrophage by MCSF, and then other variable myeloid cell by GMCSF. So this is very well known in dogma in this hematopoiesis area. But today I'm gonna share another cytokine work in hematopoiesis IL-17 family. So before I go directly into my topic, I wanted to share the basic information about IL-17 family and their receptors. So as you all know, there are several subset of IL-17 family, including AF, C, B, E, A, and then what this has been mostly known is action of IL-17 in terms of inducing autoimmune disease and related inflammation by signaling through its dimer receptor IL-17RA and IL-C, and then by this signaling, the adaptor molecule inside the cell, like ACT1, is stimulated, and then they give stimulation of NF-kappa B and MAP kinase pathway, which eventually induce Th17 cell related immunity and then inflammation in autoimmune disease. But today, my focus is on other subset, IL-17E, which is also known as IL-25. So what is known so far is that this new subset of cytokine signals through another dimer receptor, IL-7 dimerization of IL-17RA and IL-17RB. And then by signaling those dimer receptors, it also stimulate ACT1 signaling, and then which eventually stimulation of mechanism and JAK-STAT pathway, which are driving Th2 related immunity. So this is what is known so far. So because we've been interested in like a new cytokine, such as like I-17E and those receptor, I wanted to re-summarize this action between those two major cytokines. So cytokine I-17 cytokine A subtype is known for I-17 immunity for autoimmune disease response and other in like infectious conditions. However, in this IL-27E, IL-25 cytokine is closely related to type 2 immunity, occurs in allergic inflammation, parasite infection. And what is known so far recently is that this cytokine is closely associated with the ILC2 activation. And then these ILC2 cells, they produce majority of IL-25, IL-17E in like a physiological condition. So again, this cytokine is going through a dimer of IL-17 RB and RA. So this is how we started this project, because we are interested in this specific cytokine. So first thing we usually do is that checking the genetic level of those gene various immune cells website. So when we screened this ImGen website, of course, there are several immune cells expressing those IL-17E receptor genetic level. But of our note, several variable hematopoietic stem cells, including LSK and progenitor cells, are highly express the genetic level of those IL-17E receptor. So we did this, we made a hypothesis that, yeah, maybe because these hematopoietic stem cells are expressing a receptor for IL-17E, maybe they get the signal from IL-17E, and then there got to be certain regulation by this receptor and cytokine axis on hematopoiesis in the immune cells. So with this, we first asked whether this IL-17E working on hematopoietic stem cells, and then how with this stimulation, how they give way to the lineage differentiation of from the beginning, whether they are going to becoming myeloid cells or lymphoid cells. If they're becoming like a lymphoid cell, they got to be supposed to differentiate into T cell or B cell. Otherwise, if they are becoming like a myeloid cell, they're going to be becoming various myeloid cells, such as like granulocyte, monocyte, dendritic cell, and even like erythrocyte and platelet. So the first thing we made a hypothesis is that because these hematopoietic stem cells are expressing genetic level of those IL-17 receptor, so we made the assumption that these cells getting the signal from IL-17E cytokine, and then they give rise to certain lineage of myeloid cell differentiation. So to begin with our study, we prepared the primary bone marrow cells, which contains a lot of hematopoietic stem cells. And then we collected the lineage negative bone marrow hematopoietic stem cell, excluding T cell and other differentiated myeloid cell. So by using this c-KIT and SCA1 positive cell staining, we were able to separate them out into MP, which is multipotent progenitor cell. And then c-KIT and SCA1 double positive cells are LSK cell, which are known as hematopoietic stem cells. So first, we wanted to ask whether our ImGen genetic level is confirmed by this protein level in our hands using those primary bone marrow cells. So what we first did is we examined the expression level of receptor RA and RB, even without the R25 signaling. So as you see here, there's not much change in RA expression in those bone marrow hematologic centers. However, as you see here, in LSK cell especially, the RB expression level was highly induced in those population, and of course, some of those multipotent progenitors. So with this, we knew that hematopoietic stem cell expressing the IL-17E receptor and especially the RB expression among those hematopoietic stem cells. So with this, we asked whether, because those hematopoietic stem cells express receptor for IL-17E, then we wanted to ask whether IL-17E stimulation priming might expand those hematopoietic stem cells and then they are like interactive. So what we did is we prepared the same cell, the primary bone marrow cell, and then get the lineage negative cell, which contains only hematopoietic stem cells, and then stained them with the c-KIT and SCA1 again, and then examine the population level change by treating recombinant IL-17E cytokine, whether this cytokine priming expand those hematopoietic stem cell population. So as you see here, when we treated IL-17E, those LSK cell, which is hematopoietic stem cells, are significantly expanded. And then among those cells, we further examined the subset of those hematopoietic stem cells by staining CD48 and CD150, and then treated them with IL-17E, and then found that those subset of LSK cell, MPP1, MPP3, MPP4, which is multipotent progenitor cell subset, were also expanded by priming with IL-17E. So this data tells that, yeah, IL-17E priming promotes certain hematopoiesis using the receptor expression. So far, what we've been knowing is that, yeah, these hematopoietic stem cells express the receptor of IL-17E. And then next, we asked whether those IL-17E, how they make these hematopoietic stem cells lineage to, whether lineage to myeloid cell progenitor or lymphoid cell progenitor. Yeah. So anything? So am I good to go?
You can continue, Prof.
Okay, all right. So next, we asked them whether they are going into myeloid cell lineage or lymphocyte lineage. So we prepared the same cell, primary bone marrow cell, and then we treated them a little bit longer time point to track down where they are differentiating. So we treated them basically the basic simulation with the SCF, stem cell factor, and then together without IL-17E recombinant cytokine for 2 weeks. And then we examined the stem cell marker of those cultured cells in the presence of IL-17E. So other things was not really changing, but what was changing was expression level of CD16 and 32 among those myeloid cells in the presence of IL-17E. So this level is indicating the common myeloid cell progenitor. So we were able to see that by priming IL-17E signaling, they are expressed significantly more of common myeloid cell progenitor. So with this data, we were able to see that, yeah, this IL-17E signaling leads to differentiation into myeloid cell lineage. And then we next asked whether this myeloid cell lineage by IL-17E make those progenitor cell into which subset of myeloid cell among granulocytes, monocyte, dendritic cell, and or even erythrocyte and platelet. So to answer this question, we again prepared the total bone marrow cell and then treated them with different cytokine MCSF, GCSF, and GM-CSF flatter ligand. Because those cytokine are very helpful to differentiate into specific myeloid cells. So MCSF for macrophage, GCSF for granulocyte, and GM-CSF for sometimes granulocyte macrophage, and FLT3 ligand for dendritic cell differentiation. So we treated those bone marrow cells in the presence of those each differentiating cytokine in the presence or absence of IL-17E signaling. But however, among those three cytokine treatment didn't change any differentiation level in the presence of IL-17E. However, when you see this MCSF condition, when we treated them with IL-17E, the macrophage level was a little bit increased. So we assume that, yeah, maybe this IL-17E signaling is responsible for macrophage differentiation. So we further examined then to confirm that we sorted the myeloid progenitor cells and then dissect them into more detail whether IL-17E priming would make them more like a macrophage in the presence of MCSF. So we compared just control cell and then IL-17E treated cell in the presence of MCSF. So as you see here, when we treated IL-17E, the majority of those myeloid cells are becoming macrophage, but regardless of certain level of granulocyte and monocyte. So with this, we were able to see that, yeah, IL-17E signaling promotes macrophage differentiation in the presence of this MCSF condition, where the macrophage and monocyte driving condition is provided. So then next we wanted to ask whether, so far we've been investigating this IL-17 effect on hematopoiesis in vitro using the cell culture system. Then we wanted to ask whether this IL-17 signaling axis is controlling the hematopoiesis during the immunohematopoiesis condition. In other words, in disease condition. So we first tested them with the LPS injection into the mouse model. So as you know, LPS is like a very potent antigenic stimulator mimicking the antigenic stimulation and infection condition. So when we simply injected the LPS into the mice and then examined the IL-17E receptor RB expression level among each hematopoietic stem cell level, as you see when we treated LPS, those IL-17E receptor RB expression was significantly increased. So this tells that, yeah, LPS is like a very valuable related model to mimic the IL-17E signaling in this animal like antigen stimulation model. And using those, we confirmed the genetic expression level using bulk-seq RNA-seq. So among many pathways, when we treated those mice with LPS, the bone marrow cells are highly increased the cytokine and cytokine receptor interaction pathway. So among those groups, we were able to pinpoint several genes such as CSF1, CCL5, CXL10, and CXL3, which are closely related to CSF1 and MCSF axis gene, which might tell us that this LPS injection mimicking the IL-17 signaling, which working for macrophage differentiation from the bone marrow hematopoietic stem cells. So with this, we applied this LPS injection model using IL-17 injection. So what we first did is preparing just B6 mice and then treated them with LPS to stimulate the condition for IL-17E receptor expression. And then subsequently, we injected recombinant IL-17E cytokine into those mice. And also at the same time, we treated them in another group, neutralizing antibody for IL-17E to make sure that the following effect is IL-17E specific. So as you see here is that we prepared the three different animal groups, just control group, LPS only, and then the second one was LPS treated one with IL-17E recombinant protein injection, and then the other one is LPS, but we wanted to block the IL-17E signaling by injecting the antibody for IL-17E. So we prepared those three groups and then examine the population level of each subset of hematopoietic stem cells. So as you see here that we were able to mimic the in vitro data in this LPS and IL-17E injected model. So when we injected IL-17E, those hematopoietic stem cells were expanded. However, interestingly, when we block the IL-17E signaling by those neutralizing antibody, those increasing effect was deficient. So deleted this IL-17E derived effect in myeloid cell expansion, even in the presence of LPS. So we were able to tell that, yeah, this hematopoietic stem cell expansion, hematopoiesis by IL-17E is very specific phenomenon. And then finally, we confirmed that in macrophage differentiation, we did the same thing, the same model, and then we additionally treated those bone marrow cells from those IL-17E and LPS treated mice, and then re-stimulate them with the MCSF to see whether if the differentiation by IL-17E is specific for macrophage and monocyte. So when we compared those monocyte and macrophage population, and among them, the macrophage population was highly induced by this LPS model. However, when we treated them with the neutralizing antibody, this differentiation was somehow blocked. So we were able to validate that in this animal model that function of IL-17E was on macrophage differentiation from bone marrow originated hematopoietic stem cell. So to summarize my study, so IL-17E receptor, RB receptor level was confirmed in those hematopoietic stem cells. And then the cytokine signaling by IL-17E promoting those hematopoietic stem cell expansion. And then those IL-17E and IB receptor axis that promote myeloid cell hematopoiesis. And this is even further make monocyte and macrophage differentiation. So with our study, we were able to see that IL-17E priming on monocyte lineage commitment in hematopoietic stem cell. And then this is also promotes MCSF dependent macrophage differentiation. So still this is a little bit early stage of the whole study. So we need to do many other things in future studies, such as applying many different disease model for infection and non-infection model, and then look at those new cytokine specific effect. And also we need to do age-dependent study, whether the aging can be affected by IL-17E derived hematopoiesis. And then lastly, we wanted to study on the intracellular mechanism, how those IL-17E and its receptor axis on macrophage differentiation is regulated. So this is it for today for my talk. And then this study was mostly done by previous PhD student Rangyan, and then my postdoc Yoonbam Lee. And then this study was also launched with my postdoc mentor, Dr. Christopher Hunter in University of Pennsylvania. And then I appreciate my funder from the Korean government. So that's it, and I'm very happy to take any questions. Thank you.
Thank you very much, Professor Park, for such an enlightening and excellent presentation. And to all participants, You may now begin typing your question for Professor Park in the Zoom Q&A box, and we will address them during our first discussion session later.
Now, moving on to our second keynote speaker representing our host country, Indonesia. It is my distinct pleasure to introduce Professor Dr. Erma Savitri MSdVM from the Faculty of Veterinary Medicine, Universitas Airlangga. Professor Erma earned her Doctor of Veterinary Medicine, Master Degree, and PhD in Basic Medicine from Universitas Airlangga, graduating as the best graduate with a perfect GPA.
Currently, she serves as a full professor in reproductive biotechnology and is also the head of the master's program in biology of reproduction at Universitas Airlangga. With over 25 years of research experience, Professor Erma is recognized for her expertise in mesenchymal stem cells culture, reproductive biotechnology, and veterinary genomics. She has led 39 national research projects, published more than 67 international scientific papers, and authored 15 reference books.
In this session, she will present mycotoxin in veterinary medicine and risks for humans. Professor Erma, we are delighted to have you with us today. The virtual floor is yours and you have 35 minutes.
Thank you. Oke, thank you Dr. Hartanto, Dr. Kiki. Assalamualaikum warahmatullahi wabarakatuh. Good morning,
Waalaikumsalam
everybody.
warahmatullahi wabarakatuh.
In this international conference moment, I will speak about mycotoxin in veterinary medicine and risks for human. Next. There are 6 key questions about mycotoxin. What is mycotoxin? Why? Why is it important to study mycotoxin? Who is affected by mycotoxin? And when does mycotoxin occur or attack? And then where does mycotoxin occur? And then last, how is mycotoxin managed? Right? What? Next. What is mycotoxin? Mycotoxins are toxic secondary metabolites produced by certain filamentous fungi or molds. These compounds are mainly produced by mycotoxigenic fungi, including Aspergillus, Fusarium, and Penicillium, which can grow on agriculture, commodities, and feed ingredients. Also, fungi produce these metabolites in small quantities. Mycotoxin can exhibit strong biological activity and may cause significant biological effects and persist in feed and food, posing challenges to animal health and food safety. Next. Factors affecting mycotoxin contamination in the food chain. First, biological factors, and second, environmental factors. Third, first, and then process, and then storage, can human exposure, and then distribution, processing, and then animal health, and produce and from animal to exposure to human. Next. Why? Why is it important to study mycotoxin? Because livestock population in Indonesia tending decline. Next. But animal protein demand in Indonesia is trends to increase. Next. Is Java strategic for Indonesian livestock production, livestock population in left and right animal production? No, next. And then in Indonesia Free Nutritious Meal Program atau MBG. MBG not Mas Balil ganteng, but makanan bergizi gratis. Nah, strengthening nutrition, education, and the future. MBG target spending target food commodities, rice, vegetable, fruit, milk, and animal derived products, chicken, meat, eggs, and another. In World Food Program, school feeding programs have complex and interrelated cross-sector goals conferring education, health, and social welfare. Next. Food security, an integrated system. Food security is achieved when all components of the system work together in sustainable and resilient manner. An integrated system includes food availability, food accessibility, and then food quality and safety. Next. Livestock sector challenges. 5 challenges. First, consumption. Increased consumption of meat, eggs, and milk. Disease, new emerging disease, global warming, antimicrobial resistance, and the re-emergence of FMD, foot-mouth disease. In third, resources, increasing competition for agriculture, land, and settlements. Fourth, digitalization, the industry 4.0 revolution drives digitalization across all sectors. And then, fifth, mycotoxin. Mycotoxin contamination remains a serious threat to animal health, productivity, and food safety. Next. Mycotoxin transfer along the food chain. Mycotoxin can move along the feed food chain, posing risks to animal health, productivity, and ultimately human health. Mycotoxin in cereal at harvest, and then mycotoxin in poultry feed or animal feed, carry over of mycotoxin from feed to poultry on animal livestock, and then presence of mycotoxin in poultry meat and products animal, and then human consumption and exposure. Next. Common species used in food. Species are widely used in food for flavor and preservation. However, improper outdoor drying and poor hygiene condition and promote mold growth and mycotoxin production. Next. Mycotoxin exposure pathway. This is mycotoxigenic fungi, Aspergillus flavus, and Penicillium species. Nah, alpha-toxin B1 and ochratoxin A. Consumed food, and then direct occupation exposure, and contaminant animal. This is a health effect in human, acute aflatoxin, liver cancer, growth failure in children, and immune suppression. Next. Frozen food, a hidden risk of mold contamination. Extended storage, even at low temperatures, can allow molds to survive and produce mycotoxin, ultimately compromising feed quality and safety. Survival, growth potential, and quality impact. Next. How? How is mycotoxin managed? Challenges in maintaining livestock productivity and feed safety. Increased livestock population requires an integrated and sustainable approach to ensure productivity, animal welfare, and food safety. First, genetic improvement. Second, animal health management. And third, sustainable production system and feed quality and safety. Next, quality control before distribution. Quality control is essential to ensure that all feed and food products meet safety, quality, and regulatory standards before they enter the distribution chain. In raw material, crops, grain, feed ingredients, animal production. This is processing, preparation, and handling of feed or food products, and then mass quality control, testing, and evaluation before distribution, and then safe distribution, products that meet safety and quality standards. Safe feed and food for animal health and human well-being. So quality control checks physical quality, color, texture, odor, and then quality control checks chemical safety about mycotoxin contaminant, pesticide residues, other harmful chemical. And then third, microbiological safety, fungal growth, bacterial contamination, and other microbial hazards. So quality approved. Next, who is affected by mycotoxin? Mycotoxin can impact multiple levels of the food and feed chain. First, agriculture procedures. Second, feed industry workers. Third, animals. Fourth, animal products and food industry. And then fifth, human health as consumers. Next, impact of mycotoxin on animal and human health. Safety risks and human health problems. First, impact on livestock health. Mycotoxin in feed can impair animal health and reduce productivity, reduce performance, reduce growth rate, poor feed efficiency, lower productivity, meat, egg, and milk, and then immune suppression, and then organ damage. In second, impacts on animal product, contaminate feed, and to dairy cattle consume, and then transfer to animal product. And dairy cattle is milk, poultry is eggs, and cattle meat, and then meat chicken. And third, impacts of human health. Human can be exposed to and contaminated foods and animal products. Exposure pathway directs cereal, nuts, species, plant-based foods. And then indirect is milk, eggs, meat, animal, and animal products. And health effects, acute effects, nose, vomiting, diarrhea, abdominal pain, chronic effect, liver damage, gitu, kidney, immune dysfunction, and then infertility. Next. Impact of mycotoxin on other animal. Mycotoxin are not limited to livestock. They can also affect companion animals, exotic animal, wildlife, and animals in conservation program. First, pet animal, dog, cats, other companions animal can be exposed through contaminated pet food or treats. And then second, exotic animal, birds, reptiles, and other exotic animals are highly sensitivity to mycotoxin. Wildlife, what animal can be indirectly exposed to through contaminated environmental source of supplemental feeding. And then fourth, conservation animal, Animal conservation program or zoos may be at risk if feed of environmental conditions are contaminated. Okay, next. When does mycotoxin occur? First, pre-harvest stage, mycotoxin formation in the field. Mycotoxin contamination can begin in the field before harvest. Fungi infect crop while they are growing and might produce mycotoxin when environmental are favorable. Air risk factor in the field, high temperature, high humidity, or rainfall, and plant stress, insects damage, and poor agronomic practice. Next. Second, post-harvest stage in storage and processing risk. Harvest first, yeah, and then second is drying, third is storage, and fourth is transportation, and then processing, packaging. Next. Third, entry into feed food chain, exposure to animals and human, contaminated feed ingredient, animal exposure, metabolism in animal, carry over into animal products, and human exposure. Next. Where does mycotoxin be found? Major contamination hotspots along the food feed chain. Although mycotoxin can develop during different stages of production, their presence is closely associated with specific commodities that provide suitable substrates for fungal growth. Agriculture commodities, animal feed, and animal-derived products. Next. Global distribution and commodity hotspot. Mycotoxin can be found worldwide in a wide range of agriculture commodities and feed materials, especially in tropical and subtropical regions where warm and humid conditions favor fungal growth. This is left is major commodities frequently combinated, and then right, high risk region, yellow and highlight. Next. Carryover to animal products and human exposure. Carryover pathway in left and the center example of carryover, and then in right factor affecting carryover, in factor affecting carryover type of mycotoxin, chemical structure and stability, animal species, eggs and health status, level and duration of exposure, metabolic capacity of the animal, feed composition and nutritional status, and then management and hygiene condition. Next. Key reason to study mycotoxin. Historical wake-up call. In 1962, mycotoxin contamination was linked to the death of 10 million Turkey in London. And then second, toxic product of fungi. And then third, tropical country are high risk areas. And then fourth, acute and chronic effect. And ruminants are more susceptible. And then six, widely present in common commodities. And then seven, toxin can deposit in organ. Is very dangerous. Next. Mycotoxin producing fungi. Aspergillus alternaria, Claviceps fusarium, Penicillium, and Streptococcus are important fungal genera known to produce mycotoxin. Second, key fungal produce and toxin. Main species Flavus, Aspergillus flavus, and Aspergillus parasiticus produce alpha toxin B1. AFB1 is strong hepatocarcinogen, cause liver cancer, and genotoxic, damage genetic material. Third, occurrence in dairy animal. In dairy cows, AFB1 and AFB2 are transformed for hydroxylation in the liver to aflatoxin M1, AFM1, and AFM2. These toxins are excreted in milk and dairy products. Animals are exposed through contaminated feed. Now, fourth pathway in dairy cattle. Contaminate feed containing AFB1 and metabolic transformation in the liver from hydroxylation, and then can be aflatoxin M1 and M2, and then excreted in milk and dairy product. So risk of exposure to consumers through animal derived foods. Now about difference between mycotoxin vs other fungal products. Ethanol is fungal products, but toxic at high concentration. Antibiotics is fungal products, but toxic to bacteria. Phytotoxin, fungal product, but toxic to plants. And mycotoxin, fungal products too, but toxic at low concentration. Next. This is our research. Toxin in feed 2017 and now. Parameter stress effects. HSP 70, catalase, SOD, MDA, reactive oxygen species, cortisone, cortisol. And then for stem cell, mycotoxin can decrease of endogenous stem cell. In immunodeficiency and increase of inflammatory response. Nah, ini parameter BCL, 2, bugs, interleukin, and interferon gamma. And then effects on body organ in proventriculus, ventriculus, liver, kidney, spleen, bursa fabricius, ovary, ovarian follicle, testis, and endometrium. And then our research to hematological profile disorders, erythrocyte, leukocyte, hemoglobin, lymphocyte, and monocyte. And then research in hormonal disorders to observation in testosterone, progesterone, estrogen, follicular stimulating hormone, luteinizing hormone, dan MHSH. And then decrease performance in poultry, feed conversion rate, body weight, feed consumption, body weight gain, and mortality rate. Next. This is journal Scopus Q1 and top tier in 2024. Next. This journal Scopus still Q1 and top tier in 2025 and until now. This is a book about mycotoxin, our book, and patent for produce mycotoxin detoxifier. Next. This is about opinion. Racun misterius di pakan ternak bom waktu ketahanan pangan Indonesia. Next. This is a research 3 about mycotoxin detoxifier in animal, yeah, in animal feed additive and mycotoxin detoxifier. We will produce feed additive mycotoxin detoxifier as multi-component anti-mycotoxin for all with brand Mycotrace. First, anti-mycotoxin, three anti-mycotoxin. First, mycotoxin binder. AFB1, AFB1 is a toxin polar. Must to binder and reduce toxin in body animal. And second, mycotoxin modifier, non-polar toxin in ochratoxin from toxic substance can occur not toxic. And then third, mycotoxin enzymatic, DON, ZEN, and FUM enzymatic hydrolysis. So it becomes a non-toxic material. And next, this is a research team from Indonesia, from UNER, Prof. Heri Purnabasuki, Prof. Tita Damayanti, and then in UNPAD, Prof. Siti Daroja, and then in Yamaguchi, Prof. Mitsuhiro Takagi, and Seoul National University with Prof. Gojang. This study involved 25 undergraduate students, 15 master students, and 2 doctoral programs. Next. This is roadmap of our research journey. First in 2017, until now, we will produce feed additive mycotoxin detoxifier with brand Mycotrace. Next. Our research background need in food, need complete and quality nutrition in broiler feed, contaminants mycotoxin, so damage to various organs. Our research focus, alternative feed additive, induction of stem cell and immune booster of broiler, improvement of broiler health and human health that consume better animal performance and safe food for human. In center ini not only mycotoxin binders, but mycotoxin binder, mycotoxin modifier, and mycotoxin enzymatis. So multi-component anti-mycotoxin is called mycotoxin detoxifier with brand Mycotrace. Next. Mycotoxin research with my student undergraduate. Next. In this research mycotoxin. Next. Mycotoxin research with online with Prof. Mitsuhiro Takagi and Prof. Gojang. We always online by Zoom for discussion in mycotoxin research. Next. Mycotoxin research. Next. No risk management proses diperlukan ini risk management proses. Identify risk, assess risk, control risk, and review control. Next. Risk management, the definitionnya, how it works, and benefits. Next. Next. Who is impacted by risk? Nah, ini animal production and food safety involve many parties. Risk can affect various stakeholders, including animal breeders, owners, farm workers, animal feed companies, consumers. government and regulators, environment, the economy. Next. Next. Now about SWOT analysis. Strength. High protein awareness in livestock, support for MBG, gitu ya, free nutritious meals program, available of pet and exotic animal products, support for animal conservation program, commitment to animal welfare, growing demand for animal feed, strong and developing animal feed industry. Next. Now about weakness, but not weakness, yeah. This is a challenges. Indonesia is tropical region, limited knowledge, feed quality, raw material, manufacturing process, and storage management. Quality control of animal feed, ASU, aman, sehat, utuh, and halal. Feed quality examination, laboratory, and safe mark available is halal. Next. Quality control approval stamps, yeah, need quality control approval this, yeah. Next. About opportunity, increasing number of animal feed factories, available of animal feed that is safe, healthy, and quality assured. Next. Now about treats, difficulty in finding animal feed factories that can ensure feed quality, ASU, ya, aman, sehat, utuh, and halal. And then animal feed factories may be closed or bankrupt. Next.
Excuse me. Oh, okay.
Okay.
Thank you, Prof.
Yeah, okay, thank you very much.
Thank you very much, Professor Erma, for such an enlightening presentation on mycotoxin detoxification in animal production systems. Your presentation has provided valuable insights on improving animal health, enhancing food safety, and minimizing the risk of mycotoxin exposure to humans. Thank you for sharing your remarkable research and profound insights with us.
So, distinguished participant, we now open our first discussion session for the next 20 minutes. I would like to invite Professor Jung-Ho Park and Professor Erma Savitri to address the question from the audience. We will begin with the question that submit through the Zoom Q&A box. If you would like to ask your question directly, please use raise hand feature and our team will unmute your microphone. So we already have a first question in here for Prof. Jung-Ho Park. Yeah, so Prof, actually this is question from the student from Faculty of Veterinary Medicine Universitas Airlangga. So Prof, based on your findings, do you think targeting the IL-17A or IL-17RB axis could be translated into therapeutic strategies for inflammatory diseases? And what would be the major challenges before clinical application actually? That's the first question
Okay.
for Prof. Joe. Yeah.
All right, that's yeah, great question. So that is the question that I aiming for our next study. So what is known for this cytokine is about like a Th2 immune responses. So I guess maybe certain like a parasite infection model like a helminth and other Th2 may be related to any autoimmune disease. So we can maybe control the severe inflammation, excessive inflammation in those type 2 immunity related disease can be used as like a therapeutic purposes. But I don't know still, but that has to be done in my like future studies.
Okay, thank you so much, Prof. Okay, continue to the second question.
Yes, moving on to the next question. This one is for Professor Erma. So there's a question from participants about your presentation highlighted multifunctional mycotoxin detoxifier systems. So how do you evaluate their efficacy against feed contaminated with multiple mycotoxins simultaneously?
Okay. My feed no, we will produce feed additive mycotoxin detoxifier as multi-component anti-mycotoxin for all. Mycotoxin including third toxin ya, polar, non-polar, and enzymatis and enzyme. And then need mengatasi apa? Need resort to third resource of toxin, mycotoxin. For polar toxin, AFB1 ini mycotoxin for need mycotoxin binder to binder and reduce toxin. And then mycotoxin modifier. Ini for toxin non-polar like ochratoxin. So need mycotoxin modifier for because substance toxic non-polar toxic can occur not toxic, transform toxic and substance to non-toxic. And then mycotoxin enzymatic like DON, ZEN, fumanisin need enzymatic hydrolysis. So it becomes a non-toxic material.
Okay, thank you, Professor Irma, for the answer.
Okay, so the next question go for Prof. Jungho again. So, Prof. Jungho, the next question is, your study demonstrate that IL-17A bias on HSPC towards monocyte lineage commitment. Do you have any insight into the downstream signaling pathways or transcription factors responsible for this lineage bias, such as STAT5, NF, KB, or PU1, something like that?
Yeah, the answer is I don't know yet still, but what is known and what we are trying to do is looking at something like a JAK stat pathway, like a stat 1 and 6, but we don't know. But rather than the conventional intracellular pathway, I would like to examining the more like a novel pathway, and then the pathway is not standalone. So the macrophage and monocyte is not standing alone. So I wanted to expand our like a mechanism study into how those intracellular mechanism are affecting like adaptive immune cell. For example, like a T cell, Th2 T cell immune cell differentiation and functioning. Yeah, but because answer is I don't know yet.
Okay, thank you so much, Prof. So we will go to the next question.
Yes. Next question is to Professor Irma again. So, are there any concerns that long-term use of microbial or enzymatic detoxifiers could negatively affect the gut microbiota or nutrient utilization in animals? How about that, Prof? I'm sorry, Prof. Maybe you can unmute your microphone.
I'm sorry. Oh, okay. About mycotoxin enzymatic is different with bipolar, toxin polar, and non-polar is different. Source three source mycotoxin yaitu is polar, non-polar, and enzymatis. So terapi is different for mycotoxin enzymatic like DON, ZEN, and fumonisin cannot binder in body of animal, cannot modifier like non-polar, but must enzymatic hydrolysis. So it becomes a non-toxic material. This is my answer.
Okay, thank you, Professor Erma.
Okay, we will go for the next question. This is for Prof. Jongho again. So, Prof, considering that IL-17A promotes monocyte production during inflammation, could excessive IL-17A signaling contribute to inflammatory or autoimmune diseases characterized by monocytosis? Yeah, that's the question, Prof. Yeah.
Yes, but I don't know. Maybe probably not because most of the autoimmune diseases regulated by the clinical symptom is regulated by IL-17A, not E. So this is like a more like a Th17 response, and also by interferon gamma and TNF alpha Th1 response. So probably not really, but I'm seeing the question in the chatting room that somebody was asking about the eosinophil differentiation during the parasite infection. So maybe this is more likely to be clinical context. In terms of the clinical context, this is more related. So seeing this question, maybe, yes, in certain question, I see some sign of differentiation the into granulocyte, including the eosinophils. So maybe rather than autoimmune disease condition, maybe in those parasite infection condition or allergic reaction, maybe this IL-17E stimulation can drive them into excessive granulocyte, including eosinophils. So maybe controlling the IL-17E signaling, maybe we can more better control in those type 2 excessive immunity. Yeah, and also type 2 excessive immunity can be also related to autoimmune disease. So yeah, so question is always open.
Okay, thank you so much, Prof. So we go for the next one.
Yes, and now to Professor Erma. So, in your opinion, what emerging technologies or what innovation that do you believe to have a great potential to improve mycotoxin prevention and detoxification in the future, maybe in the next 5 to 10 years, Prof?
Okay, okay. For riset, next riset produce feed additive mycotoxin detoxifier in final products, but in first before harvest ini need riset for manage for anti-mycotoxin for anti-mycotoxin riset in first not in final. In my research is in final anti-mycotoxin, but need before final So mycotoxin contamination is a problem occurring throughout the production chain, including crop cultivation, feed ingredient, storage, and animal exposure. Fungi such as Aspergillus, Fusarium, and Penicillium can produce toxin under favorable conditions, especially high moisture and suitable temperature and damage raw material. So controlling contamination only at the final feed production stage cannot completely eliminate mycotoxin that have already developed. Therefore, effective management requires an integrated mycotoxin management approach, combining prevention, monitoring, and mitigation strategies throughout the production chain. This is my answer, Dr. Kiki and
Okay,
Dr. Hartanto.
thank you very much, Professor Erma.
Okay, so we will go for the next question. So for Prof. Jongho again, what do you consider the biggest remaining challenge in translating these findings into clinical application?
Oh yeah, yes. So I'm not really clinician. So I'm more of a immunologist. So I'm more focusing on the basic immunology biology. However, this is really valuable question, and also I see the question from Rani from chatting the session. So she is also asking whether this can be applied to the tumor environment control. So what can yeah, I don't know still yet, but I have very preliminary data that when I injected this IL-17E cytokine into certain tumor model, I cannot say which tumor model for now, but we were able to see some tumor volume change by this cytokine. So I guess, but I don't know still yet which is really regulating this, but there are two different things. Those macrophage can be M1 macrophage or M2 macrophage by this hematopoiesis. So in emergency condition, this can be M1 macrophage, but in tumor condition, maybe M2 macrophage is more like expanding, and then they more inducible to regulatory T cell. So they make all like a tumor friendly condition. So the implication for the clinical study is that maybe controlling this M2 macrophage and then tumor friendly immune cell environment controlling by this new cytokine and their receptor axis, maybe we can apply this study to tumor therapy or just tumor pure study. Yeah, good question.
Okay, thank you so much, Prof. So we will go for the next question. We're still waiting for the committee to show the question.
So while waiting, is there any live question from all of participants? So if you want to deliver a question directly, you can use a raise hand option and unmute your microphone.
Okay, so for the next question, actually it's come from Professor Lucia Triswanti. It's from Universitas Airlangga. This is also for Prof. Jong Ho. So, Prof, a very interesting presentation, Dr. Jong Ho Park. If I'm not mistaken, your explanation state that IL-17E to 25 can induce stem cell differentiation, one of which is eosinophil. In cases of parasitic infection, is it possible for 217E to 25 to be an indicator of eosinophilia?
Yeah. I saw the question and mentioned that about a little bit, but in certain, so in my presentation, this is very controlled environment. So in this environment, in this like a culture condition, they are more making macrophage, but there got to be certain condition that are making more eosinophil, which is for like a granular poiesis friendly condition. So but that needs certain additional stimulation. So if we find and using certain disease model or like in vitro stimulation model without cytokine other stimulator, then we can definitely think this also related to granular poiesis, which eventually work for eosinophilia. Yeah, good question.
Okay, thank you so much, Prof. I think okay, so I think the time is up for the Q&A session for this first session.
Okay, thank you to both of our speakers. and to all participants for a very lively in the first discussion session. And now, as a token of our deep gratitude and appreciation, we are pleased to virtually present a certificate to our keynote speakers. To Professor Jung-ho Park, thank you very much.
Thank you.
And next, to Professor Erma Savitri.
Thank you very much.
Thank you very much for your wonderful presentation.
Thank you.
Okay. Thank you so much,
Thank
Prof.
you.
Okay. So, we will now proceed to our next keynote presentation. Our third keynote speaker joined us from Malaysia. It is our pleasure to introduce Datuk Dr. Muhammad Nur Hisham bin Muhammad Harun. Datuk Dr. Muhammad Nur Hisham earned his Doctor of Veterinary Medicine from Universitas Putra Malaysia and holds a Master of Science in Management from University Utara Malaysia.
In November 2025, he was appointed as the Director General of Veterinary Services of Malaysia, bringing over 3 decades of leadership and expertise in national biosecurity, livestock industrialization, and international trade negotiations. He also served as President of the Malaysian Veterinary Council and Vice President of the Malaysian Veterinary Medical Association.
Today, he will present Building Resilient Animal Health System, a One Health approach to veterinary medicine and animal husbandry. Please join us in warmly welcoming Datuk Dr. Muhammad Nur Hisham. Datuk, the virtual floor is yours. You have 35 minutes.
Bismillahirrahmanirrahim. Yang Mulia Profesor Dr. Lili Maslahat, Dean of the Faculty of Veterinary Medicine, Universitas Airlangga, Surabaya, Malaysia. Distinguished professors, researchers, veterinary practitioners, policymakers, industry representatives, and students from across the region and beyond. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning from Malaysia. It is a great honor to address the 6th International Conference on Veterinary Medicine and Health Sciences. I thank the Faculty of Veterinary Medicine and Universitas Airlangga for this invitation and for creating a forum where science, policy, and professional practice can meet. The theme of this conference, Building Resilient Animal Health System, a one health approach to veterinary medicine and animal husbandry is highly relevant to Southeast Asia. Our country shares system and people and goods move frequently across the borders. These connections shape the way animal health breeds emerge and the speed at which they can spread. For those of us serving veterinary services, resilience is a very practical concept. It becomes visible when a warning from a farm reaches laboratory quickly, when the result is understood by decision makers, and when the response continues to function under pressure. Regional resilience extends this chain across national borders. This morning, I would like to reflect on how we can meet a chain strongly. I will draw on Malaysia's experience and consider how cooperation with Indonesia and our Asian partners can improve regional preparedness. Animal health has a direct bearing on national well-being. Early disease control protects communities from zoonotic exposure and help farmers preserve their livelihoods. It also supports a stable food supply and continued confidence in trade. Much of this work takes place beyond public view. An unusual sign reported by a farmer may lead to field investigation and, where necessary, laboratory confirmation. When the chain works well, action can begin before the event develops into an emergency. This preventive capacity makes veterinary services an essential part of national health security infrastructure. The regional dimension is equally important. Southeast Asia's growing animal production system operates alongside dense population and rich biodiversity. These conditions create frequent contact between animals, people, and environment. Diseases such as avian influenza, African swine fever, and foot and mouth disease can follow trade and movement routes across borders, while climate change continues to alter established pattern of risk. These realities are familiar to Malaysia. Our understanding of preparedness has been shaped by direct national experience, particularly during the Nipah virus outbreak in 1998 and 1999. Our outbreak developed with pig farming communities and became a serious public health emergency. It resulted in 265 cases of acute encephalitis, 105 deaths, and the killing of more than 1 million pigs. The impact extended far beyond epidemiological figures. Family lost loved ones, farming community lost livelihoods, and the country faced difficult decisions while evidence was still emerging. The turning point came when Malaysia scientists isolated and identified a novel paramecium virus. This gave the country a clearer basis for control. The response then drew together veterinary and public health authorities, with support from universities, security agencies, and international partners. Farmers and affected communities also carried a difficult share of response. Nipah remains part of Malaysia's institutional memory. It shows why an unusual animal health signal deserves early attention, and while diagnostic findings must reach those responsible for control without delay. It also taught us that cooperation during an emergency depends on trust building during quieter periods. The value of this experience lies in what we continue to bring from it. Preparedness depends on institutions that retain lessons, strength, capabilities, and adapt as risk change. This brings us to practical foundations of resilient animal health system. Distinguished colleagues, a resilient system begins with institutions that understand their responsibilities and professionals who carry them out. Field surveillance and laboratory evidence guide decisions, while prevention reduces the pressure placed on the response system. Emergency preparedness brings this function together when the country faces disruption. The connection between these functions matters as much as their individual strength. A field observation must lead to investigation. A laboratory result must inform a decision, and a decision must reach those responsible for action. Resilient develop when this movement is reliable and familiar to everyone involved. Consider what this means at farm level. Disease pressure falls when animals have suitable housing, clean water, and sound nutrition. Vaccination and practical biosecurity add further protection. These routine measures may appear modest, yet their effect is felt throughout the national animal health system. Animal welfare is integral to this approach. Good welfare reduces stress, support natural resilience, and improve the effectiveness of herd and flock health programs. Healthier production environment reduce emergency intervention and create better conditions for responsible medicine use. Good practice also has to be workable for farmers. Technical guidance should be accessible, and investment in healthier production should receive appropriate recognition through financing or marketing opportunities. This allows biosecurity and welfare improvement to continue beyond a single project or disease event. This is why prevention deserves the same policy attention and international support that we give to emergency response. Every outbreak contains at its source preserves livelihoods, protects public resources, and strengthens confidence in food system. Prevention provides the first layer of resilience. Surveillance tells us when the situation begins to change. A constant race at the farm, market, or veterinary clinic may be the first indication of a wider event, and the system must be able to recognize its significance. People will continue reporting when they see that information leads to action. Field personnel and farmers therefore need timely feedback and practical guidance. Over time, this response builds the trust on which effective surveillance depends. Laboratories bring diagnostic certainty to this process. Once a signal is confirmed, authority can decide whether movement control or vaccination are required and communicate the risk more clearly. Maintaining this capability requires dependable sample reference, strong quality assurance, and people who can interpret the finding in their field context. Genomic tools add further value when combined with field epidemiology, animal movement data, and ecological context. A sequence can show relationship between isolates, while investigation on the ground explain what those relationships means for disease control. This is a natural area for regional cooperation. A sample may be tested in one country while expertise or reference confirmation is available in another. Strong links among laboratories in Malaysia, Indonesia, and across ASEAN would allow evidence to move more efficiently and support earlier decisions. Ladies and gentlemen, the same connection between farm practice, evidence, and professional judgment is central to antimicrobial stewardship. Healthier animals require fewer emergency interventions, allowing antimicrobial to be more carefully and effectively when treatment is needed. Antimicrobial resistance is already affecting health systems across the world. A global analysis published in the Lancet in 2024 estimated that bacterial antimicrobial resistance was attributable to 1.14 million deaths worldwide in 2021 and associated with 4.71 million deaths. Antimicrobial resistance can develop wherever these medicines are used, and its effect can travel beyond the original patient or farmer. Malaysia Action Plan on Antimicrobial Resistance 2022 to 2026 provides the national framework for addressing this shared threat. In animal health, the Malaysian Veterinary Antimicrobial Guidelines translate that commitment into professional practice. At field level, stewardship begins with a sound diagnosis and a treatment that fits the clinical needs. The farmer must then follow the prescribed course, while the medicine itself must remain quality assured throughout the supply chain. Monitoring the outcome helps the veterinarian learn from the case and improve future decisions. Responsibility is shared across the treatment pathway. Veterinarians provide clinical and health judgment, while farmers put the treatment and prevention plan into practice each day. Every partner strengthens this work by assuring management work, generating evidence, and supporting monitoring and education. Preserving antimicrobial effectiveness is a responsibility to future patients, whether they are human or animals. It is also an example of how decisions made on one farm or in the clinic can contribute to much wider health outcomes. Esteemed colleagues, the connection I have described requires an institutional foundation. Coordination becomes durable when authority is clear. Information can be shared lawfully and every agency understands who is responsible for the next decision. Resources and regular exercise then keep those arrangements operational. In November 2024, Malaysia conducted the IHR PBS National Breeding Workshop in Putrajaya. It brought the human health and animal health sectors together to examine how information moves between them and how joint decisions will be made during a health event. The discussion helped identify practical areas where coordination could be strengthened. Malaysia National Action Plan for Health Security 2025-2030 carries this direction into a national program of work. It gives agencies a basis to move coordination on zoonotic disease and AMR while testing preparedness through joint exercise. Asian One Health Initiative provides a corresponding platform at regional level. Many of the required frameworks are now in place. The next phase calls for implementation discipline. Agreed priorities must be received resources, and institutional must regularly test whether the arrangement works. Measurable progress will give regional cooperation greater credibility. Malaysia and Indonesia are well placed to contribute to this regional agenda. The shared ecosystem of Borneo shows how closely our animal health interests are connected. Trade, travel, and professional relationship and further reason for our institutions to maintain direct and dependable links. Laboratory cooperation offers a practical starting point, supported by exchanges in field epidemiology. Joint research can then address common questions in antimicrobial resistance and animal husbandry. The value of this work will greatest when findings are carried through into policy and farm practice. Universitas Airlangga has an important role in this effort. It can bring researchers into sustained dialogue with policymakers and practitioners, helping good science reach the field. ICVMHS also creates the professional relationship between which future cooperation can grow. To our colleagues and young professionals, institutions ultimately depend on people. A well-designed system can perform only when capable professionals are available where they are needed, including in the field and at the point where evidence becomes policy. The central fourth question is whether the right expertise can reach the right place at the right time. Veterinary increasingly work across clinical, epidemiological and regulatory settings, often communicating with professionals from other disciplines. They need strong supporting system and a clear pathway for continuing professional development. Universities are preparing many of the people who will lead this work. Students should experience interdisciplinary problem solving before they face a real emergency. Later in their careers, regional training and professional exchanges can deepen that experience and building lasting network of trust. As we look towards 2030, I would highlight 5 priorities for collective action. Our first priority is to institutionalize One Health governance. Joint work needs clear authority and dependable financing, followed by regular evaluation for that responsibility remains visible over time. Second, we must strengthen the link between surveillance and laboratories. A signal from the field should move quickly towards verification, and the result evidence should return to those making and implementing decisions. Third, we must sustain investment in prevention. Farms should be supported to make biosecurity, vaccination, and good welfare part of normal production practice, with movement control applied according to risk. Our fourth priority is stewardship of veterinary medicine. Product quality and professional oversight should be maintained throughout treatment, while monitoring helps us understand use, resistance, and patient outcomes. Food safety and responsible disposal remain part of that statement. Finally, we need to invest in people and partnerships. Professionals need opportunities to learn together, test plans through simulation, and carry research into field practice. Regional exchange gives that learning wider reach. These priorities are closely connected. Progress will come through steady implementation, honest evaluation, and the willingness to learn from one another. Each country will move from its own starting point, while a shared regional direction allows every improvement to contribute to ASEAN resilience. Distinguished guests, ladies and gentlemen, the future of animal health in Southeast Asia will be shaped by what we build during periods of stability. Strong institutions create continuity, while trusted professional relationships allow information to move when time matters. This foundation will determine how confidently our region faces the next challenge. Veterinary services bring an essential perspective to this work. Our task is to recognize risk early and turn animal health evidence into practical protection for communities and livelihoods. This becomes more effective when our partners understand the evidence and can act with us. Malaysia and Indonesia have the knowledge, institution, and relationship to help shape a stronger regional future. Our shared task is to turn that potential into sustained cooperation and visible results for the people we serve. Before I conclude, I would like to speak directly to the student and young professionals with us today. This future will also be yours to lead. Your technical expertise will matter, together with your ability to listen across discipline and explain evidence clearly. One health will advance through the professional trust you build throughout your careers. Let us build animal health system that help our communities face uncertainty with confidence. Through them, we can protect animals, sustain safe food production, and strengthen livelihoods across the region. Let us prepare the next generation to carry the workforce with competence, integrity, and purpose. I congratulate the Faculty of Veterinary Medicine, Universitas Airlangga, on convening this important conference. May the discussion help here lead to new partnership, useful research, and practical action across ASEAN. Healthy animal, safe food, protected people. Resilient ecosystem, that is one health action. Thank you. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
There is no sound.
Of clinical and research experience, Professor Son has led the anesthesia service at the SNU Veterinary Medical Teaching Hospital, managing over 10,000 anesthesia cases. With his philosophy of stable, safe, and systematic anesthesia. He is an expert in regional anesthesia and perioperative risk management with 58 peer-reviewed publications.
In this session, Prof. Son will deliver a lecture entitled Brachycephalic Anesthesia, a Breathless Battle for Both of Us. Prof. Honored to have you with us. 안녕하십니까 교수님 계세요?
네, 잘 들리시나요?
Okay. 네. So now the virtual floor, I will be headed to Professor Son, and you will have 35 minutes for the lecture. And for the audience, you can type your question in the chat box during the lecture if you wish to do so. Please, Professor.
Okay. Am I go?
Professor, you can start your presentation.
Okay. Thank you for introducing me for everyone. And thank you, Rina, for the invitation. This is the starter sound. Today, I would like to share one of the most challenging patients we face in veterinary anesthesia, the brachycephalic dogs. At the Veterinary Medical Teaching Hospital of Seoul National University, we have anesthetized about 13,000 patients over the past 19 years, brachycephalic dogs account for only a small proportion of our cases, but they are among the most challenging patients we anesthetize. To understand these patients, let's start with the 5 Ws and 1H. Who are they? What they do exist? Uh, what are their problems? Where do they occur? When do they become dangerous? And finally, how can we manage them in anesthesia? The word brachycephalic comes from Greek. Brachy means short and cephalic means head. In simple terms, a brachycephalic dog has a shortened skull. If we think about canine evolution, all domestic dogs originated from wolves, which have a long-headed or dolichocephalic skull. So brachycephalic breeds represent one of the extreme anatomical changes produced by selecting breeding. We usually identify brachycephalic dogs by breeds, but the cephalic index provides a more objective measure. Based on the ratio of head width to head length, it also shows that brachycephaly extends beyond the classic breeds such as bulldogs and pugs. Do you know what breed this is? This is the Old English Bulldog shown in a painting from around 1790. Originally, these dogs were bred for bull baiting, and every anatomical feature has a purpose, from the powerful jaw to the short muzzle. In the other words, they were bred for function, not appearance. Have you ever wondered why we find brachycephalic dogs so cute? One explanation is the baby schema, first described by Conrad Lorenz. Features such as a large head, round eyes, and a short face naturally trigger our instinct to care for infants. Studies have even shown that these features activate the brain reward system, and this response extends beyond human babies to cartoon characters, toys, and of course, brachycephalic dogs. During the Second World War, the bulldog became a symbol of British courage and determinations closely associated with Winston Churchill. Interestingly, Churchill owned a poodle, not a bulldog. Over time, however, the bulldog's image changed. The spirit remains strong, but the body became more infant-like, with a shorter nose, rounder eyes, and softer appearance. Here, you can see how the bulldog changes over just 17 years. After bull baiting was banned in 1835, bulldogs was no longer bred for fighting, but for companionship. This focus gradually shifted from function to appearance, selecting dogs with a gentle temperaments and more baby-like features. But the changes may not be limited to appearance. In one study, English and French Bulldog were compared with the moody dogs in a problem-solving task. When the task became difficult, the Bulldogs were more likely to look to human for help rather than solve it independently. This may reflect a more human-directed, infant-like social strategy. Unlike most animals, brachycephalic dogs retain their baby-like features throughout whole life. Perhaps there is one reason they form such a strong emotional bond with people. And today's the birth rate declines in Korea, and fewer people have children. These dogs may have quietly taken the place of babies in many homes. Uh, I I don't know exact situation in Indonesia, but yeah, maybe that's why we feel such a strong emotional bond with them. They look like infants, and sometimes they can act like the infants too. So unless we ban them by law, brachycephalic breeds will continue to exist and probably keep growing in number. So we should be good handler for brachycephalic dogs. Let's look at the data from English Bulldog. This study reviews 2,481 cases between 2017 and 2021. The unstudied death rate was 3.9%, much higher than in normal dogs. About 90% of deaths happens during recovery, especially around extubations. And importantly, most deaths were related to respiratory problems. Over generations, selective breeding shortened the score, but the soft tissues did not shrink to the same extent. As a result, the tongue, soft palate, and other tissues are crowded into a much smaller space. This anatomical mismatch is the underlying cause of many brachycephalic disorders, especially airway obstructions. Let's start with the most important respiratory system. The airway begins at the nose. This is where BOAS, or brachycephalic obstructive airway syndrome, begins. Breathing through the mouth is only an emergency backup. Normal breathing should always happen through the nose. As air passes through the turbinates inside the nasal cavity, it's warmed, humidified, and filtered. This process increased the humidity to near 100% in the air, protecting the delicate respiratory mucosa from drying damage. When the airway became narrower, the airway flow speeds increased. This is called the Bernoulli effect. It creates negative pressure inside the airway, and that negative pressure causes the soft tissue, like the soft palate and laryngeal walls, to collapse inward, making breathing even harder. Fluorescent radiographs are not required for every anesthetic patients, but they are particularly valuable in brachycephalic dogs. On the left side, the flattened thorax, tortuous trachea, and limited thoracic space suggests reduced inspiratory reserve and possible dynamic airway collapse. Fluoroscopy allows us to observe the airway during respiration, making dynamic collapse much easier to identify and diagnose with greater confidence. Here you can clearly see the airway narrowing during inspiration on the left. These preoperative evaluations are important predictors of the post-operative respiratory complications. Based on the Sapling index, these patients would be classified as brachycephalic dogs, maybe Maltese or something. After anesthesia and extubation, these patients developed stutter, which has not been present before. Just before this case, we had very similar patients who unfortunately died after extubation. So our team was very alert and responded immediately. We provide aggressive oxygen therapy and closely monitored the patients throughout recovery after anesthesia. Even the patients were treated in the oxygen chamber. This was the condition the next day. During inspiration, you can hear a very loud noise or airway resistance has clearly worsened. Normally, when the inhaled, the intercostal muscles and the diaphragm work together, so the chest and abdomen expand at the same time. But in these patients, the inspired air volume was not insufficient, so while the diaphragm kept pulling down, the ribs were drawn inward instead of expanding. This is the classic sign of the paradoxical breathing, severe upper airway obstruction causing the chest to collapse during inspiration. Here, we compare the post-anesthesia chest X-ray with one taken before anesthesia. At first glance, the lower image looks like a trachea collapse, but a single anesthesia and intubation irritation cannot create true trachea collapse. What actually happens is that the negative pressure generated during inspiration was not properly released, causing the trachea to narrow dynamically. If the trachea cartilage is strong, it can resist this pressure. But in these patients, the cartilage simply could not withstand the negative pressure, so the trachea collapsed inward during each breath. Of course, when a patient is struggling to breathe, it can be difficult to take on X-ray, thoracic X-ray, but whenever possible, we should check the thoracic X-ray under oxygen support to confirm what's happening inside of thorax. Over the next 4 days, we repeatedly perform intubation and extubation while providing oxygen therapy, nebulization, and steroids. However, there is no significant improvement. The patients continue to show severe airway obstruction and could not maintain the oxygenation without support, so we decided to perform tracheostomy. Immediately after the procedure, the patient's laryngeal swelling began to subside, with the airway no longer irritated by repeated intubation. The inflammation resolved quickly. Remarkably, within 1 day, the patient was stable enough for discharge. There's no paradoxical breathing. Do you take chest X-ray for every patient before anesthesia? Again, of course not. It's not mandatory in every cases, but in my opinion, for brachycephalic dogs, I believe is absolutely essential. Even if they look fine, many of them have hidden airway or thoracic problems. What's about fluoroscopy? Some hospitals don't have the equipment, and even if you do, it's not practical to use it for every patient. So you must rely on your stethoscope. Good auscultation is critical. Listen carefully for abnormal breathing sounds, reverse sneezing, stutter, stridor, 구조형kin cough. These sounds often indicate which part of airway is narrowed. Particularly, stridor with stutter is very dangerous. Problems in the nasal cavity are common, but they rarely cause death directly. The real danger starts at the larynx and the entrance of the trachea. For air to reach the lungs, it has to pass through the narrow gateway. So, if this area becomes blocked or collapsed, the risk of death rises dramatically. So, in the brachycephalic anesthesia cases, I think laryngeal examination during intubation, even to short time, is very important. Among all four phases of anesthesia, pre-anesthetic, induction, maintenance, and recovery, the recovery phase has a highest mortality rate. The remaining causes are post-operative pain, cardiovascular instability, and most important, hyperventilation after extubation. Normally during recovery, we extubate when the patient starts breathing on their own and when the gagging reflex returns. But in the both patients, this timing has to be delayed. This period showed the requirement of delayed extubation. Oh, I'm sorry. And here you can see the use of an airway exchange catheter. We can call it AEC. It allows continued oxygen delivery, and if the airway collapses again, you can perform immediately re-intubation through this catheter safely and quickly. This case showed the postmortem findings of patients who suffered a brainstem injury and was maintained on mechanical ventilation for 2 days. When we examined the airway, we found clear evidence of dry damage of trachea. This tells us that with the proper humidification, the airway mucosa dry out, leading to episorial injury. The simple way to prevent this is to keep the mucosa moist by spraying stoner water or covering it with wet gauze. For patients showing labored breathing after extubation, providing oxygen is of course essential. But in addition to oxygen, we also need to think about the preventing dry damage and tissue edema. There are several cases reporting this to reduce airway inflammation, minimizing edema, and help stabilize breathing during recovery. the term high flow in HFNC means that when the patient inhales, the machine can deliver all the airflow they need. This is the key difference between HFNC and conventional oxygen therapy. HFNC doesn't just providing adequate flow, it also maintaining the right oxygen concentration, humidity, and air temperature, creating a more stable and comfortable breathing environment for the patients. This patient has both upper and lower airway injury after anesthesia. We are applying high flow nasal cannula HMP therapy for about 3 to 4 days, and the patients recovered well. In the past, we would have managed such a case with re-intubation, but that approach requires anesthesia and also constant oxygen and humidity control. HFNC machine allows us to support the patient's breathing without re-intubation in a much less invasive way. For hospitals with many brachycephalic dogs, I believe this is the must-have piece of equipment. It provides safer airway management, better recovery, and greater comfort for both the patients and the clinicians. High concentration oxygen therapy is essential part of the respiratory care. In long-term oxygen treatments, the most important goal is, of course, to avoid hypoxia. However, the opposite risk, to avoid hypoxia. However, the opposite risk, hyperoxia, is often overlooked. With modern advanced in oxygen delivery system, we are becoming better and better at treating hypoxia itself. But we must also remember oxygen toxicity. Even 100 oxygen can cause lung injury if used for more than 12 hours, and 50 oxygen can be harmful if continued for more than 24 hours. That's why oxygen, just like any other drugs, must be given in the adequate dose to avoid oxygen toxicity. This patient underwent a craniotomy that lasted about 9 hours under 100 oxygen. After surgery, I was concerned about oxygen toxicity, so we carefully adjusted the oxygen concentration to 30% for the next 12 hours during recovery. Later, oxygen was delivered through a neck collar. It's hard to imagine that the patients would actually receive 100% in this situation, but by coincidence, we measured the arterial oxygen pressure at that time, and surprisingly, it was content with a 100% oxygen exposure level. Eventually, the patient went into respiratory failure, required CPR, and unfortunately passed away. We found white exudate inside the endotracheal tube, which is a finding often seen in oxygen toxicity cases. The problem with oxygen toxicity is that there is no clear diagnostic test, and we usually diagnose it based on the situation, prolonged exposure to high concentration of the oxygen, and compatible symptoms. And once it develops, there is no specific treatment method. That's why preventing is absolutely essential. When the inspiratory flow is not sufficient, strong negative pressure in the thorax build up in the thoracic cavity during spontaneous breathing. This excessive negative pressure can pull the stomach and diaphragm cranial ward, increasing the risk of hiatal hernia and other gastrointestinal complications. So this isn't just respiratory problems. It also a GI problem caused by breathing efforts. If we can't immediately improve ventilation, our next priority should be to prevent aspiration from possible vomiting or regurgitation. Here is the AHA fasting guideline. As you can see, the recommended fasting time for healthy patients is actually quite short. However, for those with a history of regurgitation, a longer fasting period is advised to allow more complete gastric emptying. Now think about brachycephalic dogs. Many of them showed retching or gagging, even when simply eating or drinking. This means their airway and GI system are already under strain. So what's the fasting duration would be appropriate for these patients? In conclusion, for brachycephalic dogs that already have or are suspected to have respiratory problems, fasting alone is not enough to prevent aspiration. Basic fasting is still important, but we also need pharmacological protection to further reduce the risk. The most commonly used drugs are metoclopramide, maropitant, and famotidine. Metoclopramide helps by increasing GI motility and tightening the lower esophageal sphincters, which prevent regurgitation. Famotidine reduces the gastric acid secretion, so if reflux happens, the damage is less severe. And maropitant is especially useful for preventing vomiting caused by anesthetics or opioid drugs. That's why it's now a standard part of the pre-anesthetic protocol for brachycephalic dogs. In the brachycephalic breeds, the more purebred they are, the larger the head and the narrower of the pelvis tend to be. That's why natural delivery is often impossible, and cesarean section are so common. During pregnancy, the increased abdominal pressure limits diaphragm movements, making it harder to breathe, just like in late-term human mothers. But in brachycephalic dogs, this problem became even worse. There are leakages, cartilage deformities, reduce thoracic flexibility. So near the end of the pregnancy, ventilation can drop dramatically. These cases showed exactly that. The patient was intubated for cesarean section, but soon developed apnea, no spontaneous breathing at all. Mechanical ventilation was started, but yet there is no ETCO2 detected, no gas exchange. In that moment, there is only one right move: deliver the puppies immediately. And as soon as the fetus were out at that time, within 5 minutes, the mother's ventilation came back. This case perfectly illustrates how brachycephalic anatomy and pregnancy physiology can combine to create a critical anesthetic situation. Even with proper intubation and ventilation, respiratory collapse can still happen just from restrictive chest movement and diaphragmatic pressure. So anesthesia procedural section in brachycephalic dogs demands extreme caution and readiness, from pre-oxygenation and airway plan to rapid delivery if things go wrong. Now let's move on to heart. In the lung, when there is no oxygen in the blood, the pulmonary vessels constrict to redirect blood flow toward the better oxygenated area. This physiological response is called hypoxic pulmonary vasoconstriction, or HPV. In brachycephalic dogs with boas, intermittent hypoxia occurred frequently, especially during sleep, stress, or anesthesia. Over time, this repeated hypoxia caused chronic pulmonary vasoconstriction and pulmonary hypertension, leading to congested pulmonary edema. In many of these patients, valvular heart disease can coexist, which further increases the cardiac workload. So, for those dogs, we must monitor not only their respiratory system, but also their cardiac function carefully throughout anesthesia and recovery. Compared to inhalation anesthesia, dissociative injectable agents, anesthetic agents such as ketamine, tend to cause sympathetic stimulation, leading to tachycardia and increased cardiac workload. In patients already at risk of congestive heart failure, this can be dangerous. On the other hand, inhalation anesthetics are more likely to cause vasodilation and hypertension, but they reduce myocardial oxygen demand, making them generally safer for patients with cardiac compromise. So, in cases where the pulmonary hypertension or heart failure is a concern, inhalation anesthesia is usually the better option. When hypertension occurs during anesthesia, fluid therapy is usually the first step. However, excessive fluid administration can lead to overhydration, which may worsen the outcomes, especially in brachycephalic or cardiac compromised patients. To manage this more effectively, inotropics and vasoactive drugs should be considered earlier. At the same time, we must carefully titrate these drugs to avoid tachycardia and hypertension, both of which can place additional stress on the heart. In short, the key is to balance volume resuscitation with earlier pharmacology support, guided by continuous hemodynamic monitoring. For rapid blood pressure control, we must be prepared not only with CPR emergency drugs, at the same time to prevent perioperative tachycardia caused by pain or stress. We should always be ready to adjust until steps and provide adequate analgesia. In other words, blood pressure stability during and after anesthesia required both pharmacologic readiness and careful anesthetic control. Of course, there are many other things we need to prepare as well. This table shows the frequency of the use of each vasoactive drugs. Ephedrine was the most commonly prescribed drugs used across all AS or unsought risk grades of patients, showing consistently high usage regardless of patient status. In contrast, dobutamine and norepinephrine and dopamine were used more frequently in AS grade 3 and 4 patients than in those with grade 1 or 2. This pattern reflects the greater hemodynamic instability and the requirement for stronger cardiovascular support in patients with high onset risk, such as brachycephalic dogs. Let's look at one more important point, the eyes. As the skull shortened during selective breeding, the eyes of Brachycephalic became more prominent. This makes them much more prone to ocular injury during anesthesia. In previous study, we found that longer anesthesia time and a greater number of the anesthetic drugs used were both associated with a higher instance of corneal ulceration. In Brachycephalic, in one severe cases, the corneal damage was so extensive that the dogs eventually required enucleation. So even though our main focus is usually the airway and heart, but we should always remember to protect the eyes, especially in these breeds. Even in non-brachycephalic dogs, tear production decreased for more than 24 hours after anesthesia. So if the patient already has keratoconjunctivitis sicca, KCS, or any pre-existing corneal dryness, there are at an even greater risk of ocular surface injury. For these cases, prescribing artificial tear or lubricants post-operatively is very good practice to prevent additional corneal damage and support faster recovery. In other words, eye protection shouldn't end when the anesthesia ends. It should continue into the post-operative period. The anatomical features of brachycephalic breeds are not just about appearance. They cause problems throughout the entire body, affecting the respiratory system, eye, skin, nervous system, and even the reproductive organs. So, brachycephaly is not just a cosmetic trait, it's a whole body syndrome. Let me ask one final question. Are brachycephalic dogs normal? There are other of them. Yes, irresistibly cute. But behind that cuteness, there are serious medical and ethical problems. As veterinarians, we need to ask ourselves, how should we respond? First, ethical awareness and professional responsibility. Conditions like BOAS are not just breeding feature. They are disease. We must see ourselves as guardians of animal welfare, not just clinicians treating symptoms. It's our duty to resist normalizing the suffering caused by selective breeding. Second, communication and education for owners. We should explain it in simple and honest terms. The hidden problem behind the cuteness, chronic breathing difficulty, eye pain, sleep apnea, and more. We must replace the praise that's normal for this breed with this is the health problem and it needs care. During anesthesia, surgery, and recovery, we also need to make sure that owners truly understand the risk and costs, real informed consent. Third, the role of the veterinarians. Above all, no matter how these dogs came to exist, they are living beings, breathing, struggling, and asking for our help. Our job is to make sure every brachycephalic dog can live its life comfortable, safely, and with dignity. To me, this breath sound of the brachycephalus is like loudest alarm clock in the world. It constantly reminds us that's why we call cute is actually a sign of struggle for every breathing. Thank you for your attention.
Thank you very much to Professor Son for your very insightful and highly practical presentation.
And now, we have reached our second discussion sessions. So for around next 20 minutes, we will have Q&A sessions. I would like to invite Professor Won Gyun Son to answer the questions from the audience. So right now we have one question. How do you counsel owners when brachycephalic dog requires necessary surgical procedure but is considered to be at exceptionally high anesthetic risk?
Actually, all brachycephalic dogs has a higher onset risk compared to the normal dogs, but all brachycephalic dogs death after anesthesia. So adjusted the onset risk, we should check the main organs function before the anesthesia. So in the lecture, I focused on the pre-anesthetic evaluation of heart and respiratory. So if they have with high risk of that major organ, after developing the post-operative management or peri-operative management, you should handle the risk of anesthesia.
Thank you, Professor. Maybe since, as you mentioned earlier, even some of the patients have to undergo enucleations after the anesthesia in brachycephalic. And as a follow-up questions, I think it is interesting to think about how the owner handles these kind of things. As we know, sometimes it can be really hard for the owner to accept these kind of things. And not all the owner understand that some clinical procedure have a risk like that. How is it generally around SNU?
So you said about enucleation complication cases, right?
Yes, just one of the example.
Actually, always there is a possibility of the post-operative complications. In our situation, the important thing is explanation before anesthesia. So we always has the consent form with the client at the time. If we get some information for that possible complication, and after anesthesia, the real complication is occurred at the time, the client understand the situation, but in the consent form, there is no explanation about that. At the time, always has some big issues or raw issues.
Okay, thank you, Professor.
Okay, now we are moving on to another question from participant. This is a question from Adia Ugraasi to Professor Son. He want to ask, do you have a preferred protocol for extubation in these brachycephalic patients? And what clinical criteria must be met before removing the endotracheal tube?
In the normal patients, as I said, the gagging reflex can make the stress. So when you see the gagging reflex, you should do the extubation. But if in the brachycephalus there is some stress in the situation, a good respiration is better important. So we delayed it. We can. So in the video, you can see the patients stand itself, but the intubation is not removed at the time. So the patient has some struggles situation due to the endotracheal intubation. At the time, we remove the ET tube.
Okay, thank you, Professor Son. Now, this is another questions from Dr. Palestine. Thank you, Professor, for your amazing presentations. Are zolazepam and tiletamin safe for brachycephalic dogs? And is it acceptable to use fentanyl as an intraoperative analgesic? If it's not, are there any other medications that you would recommend?
You can use dissociative drugs or opioid, of course, in brachycephalic dogs. The importance is monitoring and management of respiratory situation. For that, intubation is recommended. In the intravenous anesthesia, sometimes intubation is not performed for the situation. So at that time, we don't monitor or measure the respiratory situation. So due to that, I recommend inhalation anesthesia is better than injectable anesthesia. Opioid can cause the depression of the larynx reflex, but we can support the artificial ventilation during anesthesia or surgery. So it's not a problem.
Okay, thank you, Professor.
So we go on to next question, Professor Son. What strategies do you recommend to minimize the risk of difficult intubation and post-extubation airway obstruction in brachycephalic dogs?
Pardon? About the heart?
Sorry. Okay. What strategies do you recommend to minimize the risk of difficulty in intubate and post-extubation airway obstruction in brachycephalic dogs?
Yeah. Actually, in dogs, even brachycephalic airway, in dogs with brachycephalic airway obstruction syndrome, difficult airway is very rare. Sometimes the view site is not allowed to us to assess the laryngeal inlets. At the time, for intubation, we do blind intubation using tactile with index finger, or we usually use video laryngoscope during the intubation for the education or difficult intubation situation. So after intubation, the situation very similar with normal dogs. And after that, due to the time limits, I can explain in the lecture. After that, we get the arterial line and aspiration the arterial blood, and we do the arterial blood gas analysis. On the lab data, we check the lung function, such as oxygen pressure, CO2 pressure, or gradient of the lung function.
Okay, thank you, Professor. We understand that it might be difficult to explain without actually performing the example for that early previous questions. And right now we have another questions from Dr. Alfati Tamara Octalia. Thank you for the presentation, Professor. I have a question. In a brachycephalic patients with concurrent cardiac disease, how would you modify your anesthetic plan to minimize both airway obstruction and cardiovascular compromise? Would you prioritize correcting the brachycephalic airway first, or would the cardiac condition change your decision regarding the surgery?
It's a nice question and complicated question. In the brachycephalic dogs, for the DX of respiratory function, we need proscopy, and DX of cardiac function, we need echocardiography. After that, we check the risk of anesthesia during anesthesia, and then we usually in the high risk patients after intubation, arterial catheterization is performed to monitor the tight cardiovascular stability, and the arterial catheterization can support the evaluation of the lung function. So in this situation, in high-risk patients, actually we rely on the arterial catheter.
Okay, thank you, Professor. And thank you for the participant for very stimulating questions. That is probably a little bit difficult to explain without we actually performing the intubation and the practice. Thank you again, Professor.
Okay, as a token of our appreciation, the committee would like to virtually present certificates to our speakers. First, to Datuk Dr. Muhammad Nur Hisham. Thank you very much, sir. Okay, and then to Professor Wong Yun-son, thank you very much for your wonderful participation.
Thank you very much.
Thank you, Professor. And now we have reached the end of our morning keynote sessions. Today's presentations for our global experts highlight the cross-border collaboration and is absolutely essential for advancing veterinary medicine and health science. Please join me in giving a warm round of virtual applause to all of our keynote speakers, Professor Jong-ho Park, Professor Emma Savitri, Datuk Dr. Muhammad Nur Hisham, and also Professor Won Gyun-son. Thank you very much for all your contributions, professors.
Okay, before we end up this plenary session, I would like to give some information to all of participants. So after this session, we will break for about 30 minutes, and then there will be a session with 3 different topics, and then will be divided in the 3 breakout room. One is One Health, and then room 2 is Animal Husbandry, and room 3 is Clinical Science. There's a lot of very interesting speakers waiting there, and then the absence list or the presentation will be shared in the end of the session, and after that you can get a certificate. So thank you to all participants for your active engagement throughout this session. And I will now hand the session back to our MC. Have a wonderful day, stay healthy, and see you again. Thank you.
Ladies and gentlemen, next, we will take a 30-minute break. And while waiting for the next session, you are welcome to visit Breakout Room 4, which is the poster hall, and take a look at the available artworks. See you later, everyone.
Recording in progress.
aja ta, dibuat ta. Ini loh, bumbu-bumbu itu. lingkungan loh ya Kak. Saya mau potong. Ini lebih elok lah. Makanya dibisukan kayak ini. Mikrofon ada digunakan, ada dihentikan.
Good morning.
Good morning, Prof. Nice to meet you.
How are you?
I'm fine. And how about you,
No.
Prof?
Yeah, I'm just starting the day. I guess your day was already much more interesting and longer than mine, but okay.
Okay, thank you so much, Prof. Sorry, Prof. Maybe we need to wait a little bit because
Yes.
maybe 2 minutes. Is it okay, Prof?
Yeah, 100%. Should I start sharing my screen already to see if it works or not?
Not yet, Prof, because we
Yeah,
need
okay.
to have we will introduce
to
you
see.
first. Yes, and then.
Okay. All right. Okay.
Thank you.
100%.
Yes.
You just let me know when I should start.
Okay, Prof. Thank you so much.
Recording in progress.
Sorry, Prof.